Now let us consider one problem based on Muller method. Perform three iterations. Perform three iterations of the Muller method to find the smallest positive root of the equation f of x equal to x cube minus 5x plus 1 equal to 0. Solution. Always first locate the interval in any iterative procedure, x cube minus 5x plus 1. So what is f of 0 value? 1, positive. F of 1 value what? 1 minus 1 plus 1, negative 3, negative. Since f of 0 into f of 1 both are having opposite signs, the root xi, exact root xi, belongs to what interval? 0 comma 1. Now the main point is, in Muller method we need a 3 approximation root. Therefore we take the initial approximations as first one, x not equal 0. See, the root belongs to open 0 1. Even though it is open 0 1, to make the problem very easy, I am considering 0 as one of the root, and x1 as 0.5 and x2 as 1. These are the three roots. Your choice. You can take x0 0.1, x1 0.2, x2 0.3, like that you can take. But I am taking, for easy calculation, I am considering x0 as 0, x1 as 0.5 and x2 as 1. Then what is f0? F0 means what? F of 0, f of x0. This is 1. And what is f1? F1 means what? F of x1. X1 means what? 0.5. Next, f2 means what? F of 1, f of x2. X2 value 1, this value what? Negative 3. Not f of 0.5. We are not calculated this. So this value is f of 0.5 is equal to, what is this? 0.5 cube minus 5 into 0.5 plus 1. This value is negative 1.375. And f of 1 is f of 2. F of 2 means f of x2, that is f of 1. F of 1 is negative 3. Okay, these values are over. First thing. Now let me start first iteration. And before going to first iteration, you write the formula. What is the Muller's formula? Muller iterative formula is what is that? Xk plus 1 equal to xk plus lambda into lambda k plus 1. Lambda k plus 1 into xk minus 1, where what is lambda k plus 1 value? Minus 2 delta k fk by gk plus or minus under root of gk square minus 4 delta k fk ck, and here what are the another required values? Required values is first one delta k 1 plus lambda k, next one gk value lambda k square fk minus 2 minus delta k square fk minus 1 plus lambda k plus delta k into fk, and ck value is lambda k into lambda k fk minus 2 minus delta k fk minus 1 plus fk. Okay, this is complete picture of Muller method, right? Now let us start first iteration. First iteration, and in this first iteration, what is first h2? What is hk value? Hk is nothing but what? Xk minus xk minus 1. This implies h2 value first. H2 value x2 minus x1, that right? K equal to 2. X2 minus x1 means x2 value is what? 1 minus 0.5, so this value is 0.5. Okay, and h1 is what? x1 minus x0. This is also x1 is what? 0.5 minus 0, so this value is 0.5. Next one, what are the required? Lambda k. Now lambda k plus 1, that is lambda 2. h2 by h1, lambda k plus 1 equal to, or lambda k equal to hk by hk minus 1. Using that lambda 2, h2 by this 0.5 by 0.5, this value 1. Then delta 2 equal to 1 plus lambda 2. 1 plus lambda 2 means 1 plus 1, 2. Next value, let us find g2. Now in formula k equal to 2, substitute k equal to 2, then lambda 2 square into f0 minus delta 2 square into f1 plus lambda 2 plus delta 2 into f2. You know all these values. Okay, substitute, you will get minus 2.5. Next c2 value, lambda 2 into lambda 2 f0 minus delta 2 f1 plus f2. This value after substituting 0.75. Now what is since? This is very important. What is the sign of g2? Since g2 is negative, or you write like this, since g2 equal to minus 2.5 is less than 0, in Muller's formula, in denominator we have to take negative sign. We have to take negative sign. Therefore, what is lambda 3 lambda k plus 1 formula now? Minus 2 delta 2 f2 by g2 plus or minus. In plus or minus I have to consider negative sign. Since g2 value is negative, g2 square minus 4 delta 2 f2 c2. Okay, this is equal to negative 12 by 2.5, taking minus common, plus under root of 24.25. this value is minus 1.616286. okay, this is lambda 3 is over. Now what is the next approximate root? x3 equal to x2 plus lambda 3 into x2 minus x1. so substituting all the values, you will get 0.191857. okay, this is the next approximate root. And what is f3? we required at the next iteration, so calculate here itself. F of x3 equal to f of 0.191857. substitute in the function. What is the equation? Our equation x3 cube minus 5x3 plus 1. put x3 value, then you will get 0.0447. okay, now second iteration. In second iteration, what is I have to calculate now? h3. H3 is nothing but what? X3 minus X2. Substituting all the values, 8143. X3 value is what? Already you got X3 value here. X2 value already we have 1. Subtracting those two. Next, lambda 3 value. And lambda 3 is H3 by H2. That is H3 by H2. H3 value minus 0.808143 by H2 value 0.5. This value is minus 1.616286, and delta 3 value 1 plus lambda 3. So 1 minus 1.616286 is equal to minus 0.616286. Next value, G3 value. G3 formula what? Lambda 3 square into F1. Lambda 3 equal to, now G3 equal to lambda 3 square F1 minus delta 3 square F2 plus lambda 3 plus delta 3 into F3. That is value, substituting every value, and the result is 9263, last result. Next, C3 value. What is the expression for C3? Lambda 3 F1 minus delta 3 F2 plus F3. And after substituting every value, the value of C3 is 680961. Now, since what is G3 value? Minus 2.559263. It is negative. Consider negative sign in lambda k plus 1. In lambda k plus 1, x in denominator of, in negative sign in denominator of lambda k plus 1. So what is the next lambda value? Lambda 4 minus 2 delta 3 F3 whole by G3 minus under root of G3 square 4 delta 3 F3 C3. Now taking negative sign common, this entire value is by 2.559263 plus negative sign is common, 6.469625, and this lambda 4 value is minus 0.11151 Then therefore, what is the next approximate root? X4 is equal to formula x3 plus lambda 4 into x3 minus x2, right? Substitute every value, and the next approximate root is this is the next approximate root. And what I have to calculate? F of x4, nothing but f4 value. This value is 0.002223. See, f of x4 means what? Substituting root x4 in the function. So in the function value is going to 0. Observe this point. Okay, next, third iteration, final iteration. Up to 3 iterations we have to do as per the question. Third iteration. Now coming to H4, x4 minus x3, substituting and subtracting the values, 009327, and lambda 4 equal to H4 by H3 minus 0.011541. Next one, delta 4 equal to 1 plus lambda 4, 0.988459, and G4 value, formula lambda 4 square into F2 minus delta 4 square into F3 plus lambda 4 plus delta 4 of F4. This is equal to minus 0.044908. Next, C4 value is lambda 4 into lambda 4 f2. Just I am substituting the value, that's it, in the general formula, and substituting every value I am getting simplified values, 3 zeros 1 2 0. Now what is g4 value? G4 is minus 0.0444908 negative. In lambda k plus 1, consider negative sign, in denominator. Okay, so what is lambda 5 becomes lambda 5 becomes minus 2 delta 4 f4 by g4 minus under root of g4 square minus 4 delta 4 f4 c4, and substituting the values and taking negative sign common, 4395 by 0.044908 plus under root of 0.002016. So this value is 0.048940. Therefore, what is the next root? x5 is equal to x4 plus lambda 5 into x4 minus x3. This value is 0.201640. This is the final value. So lastly, conclusion, after three iterations, the root is, the question is, use three iterations, the root is x is equal to 0.20164. This is the answer.